here we want to find the derivative, and we actually have two different options. We have a product, so we could just leave it like it is and do the product rule. Our other option is we could multiply this and get it so we did not have a product. Now when we multiplied it, we're still going to need a product rule on one of the steps here. But let's try to do it both ways and kind of contrast the difference so you can decide. Sometimes there isn't a right way, there's just two different ways to do the same thing. So first of all, I'm going to do it like I see it using the product rule. So here is my first factor, here is my second factor in my product. So the product rule says first times the derivative of the second, so I would need the derivative of the second factor. The derivative of z is 1, plus, and the derivative of an exponential e to the z is just e to the z. And then plus the second, and I usually write it second, so I don't kind of commute the terms, times the derivative of the first. Okay, the derivative of this first factor, the derivative of 1 is 0, and then I have a negative. The derivative of e to the z is e to the z. So now that we have the derivative of our product, let's see what we can do to simplify this. If I multiplied this out, these are conjugates, so I have 1, and we see outers and inners cancel, and I would have, for last, e to the z times e to the z, keep the base, add the exponent, so that's e to the 2z. And then looking here, I have minus z e to the z and minus e to the 2z. So we could finally express this as 1 minus 2e to the 2z minus z e to the z. I know I'm kind of close to the edge right there. Now let's look at option 2. What if we had chosen to multiply this first? First times first, we've got z, outers we've got e to the z, inners we have minus z e to the z, and lasts we have minus e to the 2z. Now if we do a derivative of this, the derivative of z is 1, the derivative of e to the z is e to the z, and here we have a product, so we would need to do the product rule, which is first times the derivative of the second, the derivative of e to the z is e to the z, plus the second, which is e to the z, times the derivative of the first, and the derivative of this negative z would just be a negative 1. And then actually I see a problem here because we have not yet learned the chain rule, and so we actually would not know how to do the derivative of e to the 2z, because what we learned was the derivative of e to the x is e to the x, or e to the z is e to the z, but we have not yet learned how to handle e to the some constant times z, and that will be coming in a later section when we do the chain rule. So I guess we wouldn't be able to do it this way until we have learned the chain rule. Once learning the chain rule, we would be able to finish it this way and then kind of contrast between which way would you rather do it. But it looks like we're going to have to get the solution by doing it this way right now.